subnet, you could still do that. And that's kind of like the default functionality and the baseline and so on, no problem. If you want to say, look for this host ID and all streams from this host ID, give me those, you can say fine. Or another functionality that now exists with Jason's tweaks is you can say, give me every EEG feed. And I don't care what it is or where it's from, but if it has the word EEG in it, I wanna record it. One other thing that Jason put in that was super cool is, and I mentioned this before, but with the baseline build of Lab Recorder, you rely on the sending device to do the timestamping, and it's part of the LSL protocol. With Jason's tweaks, we do have the ability to do receive side timestamping, and it might seem very counterintuitive or whatever, but it's actually bailed us out in 2 or 3 situations already where, for whatever reason, we didn't have control over the send time stamping.
That's great. I mean, it's great to know. I wanted to just post something, or did somebody already post something in the to give people a link to that GitHub?
So Alex, could you spell that out a little bit more, like that scenario? Or I don't know if you said that was something you actually did, or that was like a potential use case. But you got what, 2 people playing Quake and recording their EEG while they're playing Quake and doing something with that.
Yeah.
And then you just said with eye tracking as well, right?
Yes. Yeah. So we would have the full. So the idea, the very first experiment we did with NeurotechX Berkeley, of all places, back in 2016. This was really cool. So they got a professor at the Berkeley Haas School of Business to do a lecture, and then they had 5 volunteers for the lecture that were going to get recorded. And one of the ideas was to look at the brainwave similarity and the dissimilarity as sort of a way to determine who was paying the most attention to the instructor. So it was kind of an interesting concept, which is, if brainwaves are stimulus driven, then the people that are paying attention to the instructor should have more similar brainwaves than anybody who's zoning off, potentially, right? It would just be that if you're daydreaming about your dinner, your brainwave activity would look different than somebody listening to the instructor, which would be more similar. So in that case,
that's what they do for like movie viewing paradigm analyses, don't they? Yeah.
Yes. So in this case, we had 6 EEG devices that were broadcasting. And that was fine because we had 6 collector machines. You know, like we had 6 students with laptops that were paired to the OpenPCI devices and the Muse devices, and we were doing the experiment. But the idea was we wanted to robustly be able to capture any number of devices from any number of participants in any number of settings. And we wanted to be able to either aggregate the data or separate out the data as appropriate. So that's what this Lab Recorder CLI functionality really lets you do. Is the XDF is kind of like a binary blob that records all your data and metadata related to the stream and so on. So the ability to granularly subscribe to which streams, which channels, which devices, just means that when you organize your data, whether you want to have both pieces in one, or if you want to separate it out into 2 channels or anything like that, it just gives you a lot of flexibility in terms of like how you're going to organize the data.
Cool.
So, and sorry to ask this question about I'm just looking at the lab streaming layer GitHub. So under apps, I mean, I see, you know, various hardware names like Brain Amp Series, Brain Products, Cognomics, EGI Amp Server. Where would be I mean, are those all, do those all get kind of recast as like Lab Recorder, or?
No, Lab Recorder is its own thing.
It's so, okay. Am I looking?
There's one called app dash Lab Recorder. So the idea would be to open a PR on that project.
Oh, okay. I see it.
Yeah.
Okay. I see it now. Okay.
Yeah, they're
So-
all sub modules, Git sub modules now. I think they used to be
Okay.
all like one big mono repo, but
Gotcha.
Yeah.
Okay. Well, I mean, would an interim step be making the project available on GitHub before it's merged? I mean, is it functional? I mean, it's functional now, yeah?
yeah. So I mean, the easiest thing at this point, I suppose, could be to just post, the version I have, the code I have, although it might not jive exactly with the current lab recorder repository, and then I'd have probably some work to do to, basically clean up a pull request to lab recorder so that it could become part of that, and like hopefully it would just be part of their binary distribution then.
Sure.
It is a cross-platform app. This is built with Qt,
Cool.
so it works, I think, on any machine.
Yeah, nice. I mean, certainly one of the general questions we ask is there anything that you're looking for help for, or are there any stumbling blocks that you've currently got with the project that you're looking for, people interested in helping and things like that?
So I mean, this is I guess more of a question for you guys. If you're interested in trying it out, just send you a build of it, and see how it works for you.
Sure.
Yeah. But I mean, if there's no interest here, that's fine too.
So. No, we're definitely I mean, certainly this is what Alex and I were talking about in February at our first and last in-person meeting. Where the scenario that Alex painted was our use case. So it would still be easy. I mean, I've got enough computers around that I can recreate that in the house. And the one thing I would love, I guess I could go in and get that Toby bar. Is it still there, Alex?
Yeah, it is. It's actually sitting in the hotel at the moment.
Okay.
Yeah.
Okay.
Yeah.
I mean, I was actually eyeing it on eBay just a couple of days ago. And, I'm still waiting for a particular SMI system that matches Child Mind Institute, but that's a lot more. This at $100, $200 is much more attractive. So yeah, I definitely interested, Jason, and these do sound like useful features. If it's not something, if it's something that is also postable in the sense of maybe there are people who'd be interested in helping, and we haven't talked to lab streaming layer people in terms of maybe they're super interested too.
Yeah, so I'll post the code probably on GitHub. I think it's on Bitbucket right now, but I'll post it on GitHub since that's a much more popular site nowadays.
Yeah.
And then I'll post that link in the general channel on NeurotechX. People can take a look and say how bad my C++ code is.
No, that's awesome. And so can I ask a little history of BlueMuse? So yeah, I think the story I heard was that it was originally designed to kind of be PyLSL, but to get submitted to the Windows store.
I originally built that just because I was trying to do a project with like basically just detecting key presses
Okay.
with the Muse,
Okay.
which ended up just being a throwaway project because it worked so poorly. But yeah, I had to build something because I was trying to use Muse LSL, and I was trying to use it on Windows with one of those little blue BLE, peripheral sticks.
Yeah.
And it was like crashing my computer and stuff, and I'm just like, oh, this is hideous. So I had to make something like native. But yeah, it's not publishable. Maybe it is publishable now to the store, but at the time it wasn't, because it uses it basically spawns like a Win32 app, which is that like LSL bridge weirdness. It's just this whole thing. At the time, the only way to get the Bluetooth libraries on Windows was to use a Windows 10 app, not like a Win32 application.
Yeah.
So I made the app, and then the data couldn't get out of the app without this like weird bridge thing. It was horrible at the time. There's just so many weird restrictions on Windows 10 apps. Like, I'm glad, like, I think it's dead now, pretty much, Windows 10 apps. So that's probably a good thing for the future.
Right. I mean, I don't know. I don't follow it except for the Windows subsystem for Linux announcements, and they sound positive. I mean, it certainly sounds like there's potential that more kind of Linux code will actually be able to access hardware from. But
it's still pretty bad on the WSL stuff.
Yeah. I mean, it's still a weird, it's still not quite a full peer, right? And but I was curious about your experience in terms of trying to get. I mean, I see very few Windows apps that actually make it into the store. Yeah.
I mean, why even bother making a Windows 10 app if nobody's going to download it?
Yeah.
Like.
Yeah. But Bluemuse is still, it's like when I'm not quite sure that I'm having a problem on Linux, I always take my hardware and use Bluemuse to check. Like, no, it's working. It's something. It's my configuration on Linux.
Well, I'm glad it works for you, because I do get some complaints. It doesn't work for people.
Okay.
I have no idea why sometimes. I'm just like, I don't know. It's the Windows BLE stack. It's terrible.
Okay, so you're using the Windows stack in the back end?
Yeah. So people think I was using the Muse SDK, but that's not true. It's not the Muse SDK. It's just raw Bluetooth BLE.
Gotcha.
And for whatever it's worth, and I don't mean to interrupt too terribly, but when we discussed this with Jason a while back, I was asking all these questions, okay, so Microsoft actually locked out the Bluetooth radio unless you use their super walled garden UWP, which was the first stumbling block, because then, just like Jason said, you've got to get the data out of that UWP container and into the actual OS and memory and so on. So first off, Jason did an incredible amount of work just figuring out how to work around those limitations. But the fascinating part is that the end result is that the way he implemented the Bluetooth radio interaction and the packet handling and so on is actually better than the Muse SDK. Because he was kind enough to write the Curia Connect app, which is sort of like a fork of Bluemuse using the SDK officially or whatever. And we can still find corner cases where we run into pairing issues, or at the hotel when we were actually doing the test run, the Bluemuse works better because of the way that it interacts with the radio and the way that it really gracefully handles the Bluetooth packets and so on. So it's fascinating to me that, from what I can tell, the implementation of JSON is a little more robust than the official Interaxon one.
I have a question for Jason.
Sure.
So why not use the gap profile services directly? I mean, if the concept is to encapsulate devices and as profile devices. And then you, I guess, have to trust the OS vendor to give you a good driver into that protocol. But I mean, ideally, would you consider that to be a better approach or an approach you considered?
I'm not sure. I'm not sure I follow. Like, you're talking about interacting with the hardware directly, not going through the OS APIs.
Well, specifically, the Muse device presents itself as a BLE device, or client, I guess, in this, or the nomenclature. I still haven't read too much into it. And then it provides a profile service that they call the Channel Attribute Table, the GAT. And that serves as a standardized profiling system. So it says, I have these channels, I have these inputs, outputs, and then you can further standardize on what is an EEG, what is a temperature sensor, what is a heart rate monitor. And so in principle, it's a lot like USB, where you plug in a hard drive and it says I'm a mass storage device. So these profiles dictate certain aspects of communication protocol. And for example, the BLED Bluetooth dongle actually presents to you a UART-based GAT interface. So you're not actually interacting with the BLE packets. You're actually talking to an API that has then processed the communication stream, has created this communication channel, and is now talking to your sensor based on these attribute tables. So based on a profile system, as opposed to a sequence of raw Bluetooth packets that you construct based on whatever scheme you do in your API. So you're kind of saying, hey, I want device this. Oh, you're a EEG. Give me your stream, and then you don't really worry about it. And so that's kind of the concept behind BLE. And so I was curious about how much digging you did into that aspect of it.
Yeah, I wasn't really aware of that type of approach at the time. So it's definitely would be something to look into now. Sounds like a much smarter way to do it.
Well, so Andre, do you know if that's, certainly like with BlueMuse, like the specific goal was to get something working on Windows, right?
No, absolutely. And I understand exactly the pain that's being described here is the walled gardens of the APIs. And they do not want to give you low-level access because they want you to go through these profile APIs, which are using pretty good drivers. At least the vendors probably write pretty decent ones. But that's kind of why they suck if you're trying to do low-level Bluetooth access. Certainly it's this topic. What is GATT? It's probably been poorly advertised, but it borrows concepts from many, many other protocols, and USB is probably the most close to heart. You plug in a hard drive, your computer says, oh, mass storage device. You plug in a mouse, it says, oh, I'm an HI human interface device compatible mouse. Those are all based upon contracts, agreements between engineers saying, this is how you're going to lay out your input-output structure. This is how you're going to advertise your channels. And all that's written in the specification. So that's what GATT is basically is this ability to use these devices somewhat more generically.
So I'm looking and certainly like it does seem that there's some Qt documentation of BLE GAT. Again, like trying to come up with something that would solve a Windows problem, but also be, an API and library that you could use cross-platform. I'm not sure.
No, it's a new concept, and it's actually was only really introduced with BLE 4. Whatever. Like that was actually only I guess released as specification in the last year or two. So a lot of the stuff takes years for it to roll through and get adopted by everybody and get shown up. But it is something that is a powerful concept. So It could be a way to fix things, but it also comes with its own problems. As you know, we've had lots of issues dealing with the GATT drivers within Python for the same reason. It's even more obscure low-level code because you're not even seeing the Bluetooth packet exchange. You're trusting some OS vendor, and that has its own suite of problems.
Yeah, I mean, I'm hoping we're gonna get to the pull request for the EEG notebooks that Blueberry gave us, which gets at some of the PyGAT issues, if I'm correct. I only looked at those. I didn't really get into them, John. I don't know if you'd had a chance to review that.
Yeah, I had a glance, and I'm gonna try. I was hoping maybe tonight, if I can fix another thing I'm trying to do, to just test some of the changes to confirm that it's not breaking anything, and then I'll merge it.
I mean, I don't know if you need a Linux tester.
Well, as far, I mean, I think he's, yeah, you can test it, but like, it's more that it probably needs a Windows tester because he did the changes are done on Linux. But yeah, go ahead.
I mean, I've got a Windows system too. like I said to Jason, like I make sure I make sure everything's working with BlueMuse, and then I try and make it work on Linux.
No, and this is the wild west of interface devices. So you're fundamentally, it's really impressive work. You run into the same cross-platform and maintenance issues that just become drags on everybody who just wants to move on and do really cool things with the system. It's somewhere, I think, a drag to keep maintaining the low level, but growing pains.
Well, I just posted a link to the pull request that has some of the things, some of the changes that he made, and yeah, I mean, it's definitely interesting, and I want to again thank JD and Blueberry for Caden's time. Yeah, certainly. I don't know about is it Blue Pie, or is that just a file?
Blue Pie is a Bluetooth Python library.
Oh, okay, so is it a new dependency that they're adding?
Yep.
Okay.
And I haven't checked what he's doing with it yet, but
okay. But I thought it was interesting too that there's like an update for M&E.
Yeah. I didn't realize that thing had been deprecated. So that was good to hear. Yeah.
I mean, yeah.
Yeah. I mean, what would be interesting to know is if the Blueberry guys are gonna be using some of these paradigms for some of their stuff. Like, we could definitely, well, it's called the EEG notebooks, but it could have FNIR stuff.
Yeah.
Functionalities there.
Yeah.
Maybe they're trying out their M170 things, or yeah. But I think actually from the discussions I had, they were more interested in a kind of, call it like a steady state working kind of paradigm, and then distinguishing between manually labeled tiredness or distraction kind of things, rather than cognitive neuroscience experiments per se.
No, I mean, it definitely, at least in the marketing, suggests that they're going a bit more like Neurosity Notion in terms of that kind of focus, that kind of something that would work well in Neurosity's kind of dashboard of this is how well you're doing.
I haven't seen what the Neurosity kind of app
No,
proposition is. What is it? Right.
I would just need to switch over to, because let me. So the NeurotechX, I mean Neurotech SF Twitter follows more of the. I use that to follow more of the. So I'm just looking for a particular tweet. He had some stuff today. But it's got that kind of like GitHub dashboard. I mean that GitHub dash, where like this is kind of like a color coding of this is how much attention you've managed today, and so now looking across time scales, you've got your how much you were sitting and wearing the Notion and getting that particular classifier with it. That particular classifier was engaged. So sorry, let me see if I can. I mean, this kind of.
Did we lose Morgan? All right. Hey, Ryan. That's cool, man. Nice to see you. But just to finish talking about the Bluemuse LSL recorder app or whatever, if there's anything to do with recording LSL data streams in a programmatic way that you'd like to do, I think this works really, really well for that. It's just a question of if that's a use case that you have. For what we wanted to do, which was sort of like this semi-automated collection and have things be kind of synchronized, we really needed to be able to feed a CLI a bunch of parameters, have it do everything in a consistent way, and make sure that we were subscribing exactly the data we wanted with the characteristics that we wanted, same naming convention and so on. But yeah, if there's I mean LSL is really awesome, but just as a transport layer in and of itself, doesn't, it's just there. But I really think that having that recorder app, especially for Windows or for any particular thing, and just being able to say, yeah, just grab all the streams, or grab any stream with EEG in it, or grab any stream from this device, save it as an XDF, save it as a CSV. By the way, the CSV, which is pretty cool, not only does it save the actual data stream, which is what you would expect, LSL has this channel metadata that it generates when the stream gets built, And yeah, all that information is captured too in a XML file. So you can see all the stream characteristics, the offsets. If you're using the jitter functionality, it will put those de-jitter timestamps in there. So yeah, what's cool about it is, yes, there's XDF and CSV functionality, but it actually stores all the data. So you're not losing anything by using CSV or XDF. Looks like Morgan's back.
Sorry about that. I seem to be having some internet problems. I'm hoping it doesn't go back to the way it was, you know, a couple weeks ago. But I will follow up with you, John, on the Notion. Sorry. What have you guys been talking?
Morgan, are you looking for a good screenshot of their app?
Sure. Yeah. If you've got something of their, I mean, would you, when you say their app, I mean, I'm thinking of their kind of like dashboard.
Yeah, I can find that. I follow AJ on Twitter and see it and post it really often. I can pull that while you focus on this.
Sure. Thanks.
No problem.
I wanted to, I mean, I'll check later about the Blue Pi, but hey, Jason, I wanted to ask, does Bluemuse, do you use Boost?
No.
No. Okay. And so I saw that I think it was LSL on Windows. One of the problems that they'd had with I think the Pi LSL version for Windows is that they needed to include Boost, and I was wondering if that if you knew some of the backstory behind that.
So what? I don't know why would that be a problem? Do you know?
Well, I think it was more just that it wasn't something that they needed to include for when they were making the Pi LSL for other platforms, and so there was a bit of a discussion. I don't know if Simon can remember this. The archaeology of this, but I think it was on the, is it the Conda Forge of Pi LSL, Simon, that there's the I'm trying to think of the developer who ended up doing the Python, doing the Windows version of Pi LSL. I don't know if Simon's still on, but
Morgan, I shared the link to the
cool
screenshot.
Thank you. Yeah, I mean that's certainly a good example of his, you know, GitHub like dashboard, and then the color coding is, you know, the amount of time that particular algorithm is showing you're in that state, right?
Yeah, I think it's specifically the focus metric.
Right. Well, I was just curious, Jason. Now, Bluemuse, is that also on Bitbucket?
GitHub.
Oh, it's on GitHub. Okay.
Yeah. Yeah.
And what is the current state? I mean, does that still get updates? Does it need updates?
It was just recently updated to support Muse 2.
Gotcha.
And apparently it also works on Muse S. That's what people are saying.
Nice.
But I don't have access to Muse S.
Gotcha.
And it also works for the sunglasses that nobody owns. And it works for the accelerometer and the gyroscope and all that fancy stuff. So it's pretty cool, I think.
So is this Neurosity device, like, is this something the community is interested in using, like as a just general purpose EEG, or is this like locked down to their like cloud platform or all that jazz, like typical.
Yeah, well, I mean, I don't know if anybody feels better able to answer that, but certainly we had AJ on, and it seemed like they were at this stage pretty, pretty clearly trying to keep it with, the dash being the interface.
So they do have like all the stuff on their interface in the cloud app, but I've asked them specifically if you can just straight up access the raw data without having to go through their cloud, and you can. So
okay.
yeah.
Okay.
I think they did explicitly specify an LSL type functionality as well, where you can just stream.
Yeah, that's right.
Yeah, I think they mentioned that they had a. Pardon.
No, you're right. Yeah, I remember that. There's like a button on the cloud dash that you press, and then you have LSL. That's right.
Right, exactly. So I think in terms of $1,000 devices, both that and the Unicorn Black have been something we've looked into and have been very interesting. So it is kind of cool that 2 years ago there was just the Emotive, which has a lot of licensing issues, but now a few years later there are these two like emerging mid-price devices where it's not 200 but it's also not 5,000, so it's kind of nice. And it looks like both of those devices are kind of at around $1,000 price point, so not cheap, but I guess plausible.
My worry is for like cheap EEGs, like the Muse is like kind of go-to right now, but their next release, I can almost, like, my gut tells me it's going to be locked down somehow. Like 100%, you won't be able to get the data, or you have to work really hard to.
Yeah, I think Neurosity will probably stick to letting you get the data. Their whole thing is that I think they're keeping their algorithms and stuff kind of locked down. So if you want the raw data, fine. But if you want to use their classification algorithms, you got to go through their cloud, which I guess makes sense.
Mm-hmm.
But I am very interested from the standpoint of I spend a lot of time setting up my open BCI headset to make sure it matches my head. And then anytime I like move some of the electrodes around, I have to go through the whole process of it again.
Yeah.
So I'm really interested in having something that's kind of like that fixed design that just extends like headphones, and being able to just plop it on, swap out the electrodes if needed. But it looks really good to just get up and running real quick like that.
And so if when you have access to the data stream, that's kind of also like saying you don't have access to their ARM chips on the Notion, right?
That's a good point. I haven't actually specifically asked about that. That'd be a good question to see if you could, access and then load your own algorithms onto the chip so that it still does the real-time classification. I could reach out to AJ and ask him about that.
I'd be curious because, I'd certainly like to be able to answer that question better than I just did. But I since we were talking about glasses, I posted another link that so Joe Arujo, who I don't know if how many people that are on tonight caught BCI 101, but Joe was very active, especially in the Neurobar social after. And so he's a PhD student at Cambridge working on machine learning of EEG for dyslexia. And kind of, I don't know if it's best to characterize it as diagnosis or actually ways in which to suggest like better educational strategies. But anyway, he posted this link in terms of glasses that certainly made me think of both Blueberry and what we were talking about with Kyle when Kyle was showing off his Muse Smith glasses. And somebody putting everything they could into a pair of glasses.
Be interesting to see someone integrate the pupil eye tracker glasses.
Sure.
Yeah, because I have the materials and stuff to make it. haven't got around to doing the surface mount soldering of infrared LED.
Okay.
That's stressful. I've already messed up one webcam trying that out. So,
well, I've got Alex's here. I've got Alex's pupil here, which I keep threatening to do something real with. But what I liked about this, plus there was some other glasses that people were using, like AR glasses that people were using to do stimulation for EEG, right? And that was our original idea with the pupil, but with with something that we could put various visual psychophysics stuff up on, and to then look at it for steady state VEEPs. So I hadn't actually gone to see, is this a particular, okay, so it's from Korea. I don't know if it's open. Okay. Electrochromic sunglasses are already commercially available. Yeah. But it is, one thing that was nice, Jason, about one thing that seemed like everybody agreed on with the Notion was that it was something you could imagine people wearing for quite a while. And I think they did a good job with the form factor.
Yeah, I've been toying around with trying to design something similar contour to my head to mount the open BCI electrodes on, just so I don't have to go through this process over and over again.
Well, I like, and so another reason why I wanted to show this particular picture was that I kind of like the idea of fitting a lot of the electronics into the glasses, as opposed to it being like, the I'm gonna say open BCI, not to blame them, but open NIRS does the same thing, right? In the sense of a lot of wearables devices put the hardware on the helmet, so to speak.
Yeah, it really displaces a lot of the weight on it, which I think is the biggest issue. Is that even with even downgrading upgrading to the rechargeable batteries, which are much smaller instead of the battery packs, it still ends up pulling too much. So I always feel like to record, I have to angle my head a little bit to keep it level.
Yeah. It would be nice, certainly, again, like when we were looking at I forget the Dutch company that makes the 16 electrodes that just go on, they're like a C strip that just goes behind the ear. Mm-hmm. Sorry?
Oh, sorry. I don't know the name, but I've seen the device you're talking about.
Yeah. It's sweet, right? So you just get this nice strip. It sticks on behind the ear, and then they're disposable. But the electronics were basically given as like a pager device, right? So that you actually just clip it to your belt, and again, like get all the weight and equipment off of the head. It's still wired though, right? It's not they're not trying to do Bluetooth or anything, but.
And by the way, that observation about the open BCI helmet weight and like the way that you have to sort of wear it, we found that to be one of the biggest surprises with all these EEG and BCI devices is there are so many quirks that you really can't get familiar with until you really try them. And I think sometimes one or the other ends up being a compelling use case, not because of the technology, but in just the form factor works for what you're trying to do. So yeah, it's really interesting. That's why anytime we get the opportunity to look at one of these, I love to check it out because it's really interesting. So I'm quite excited about the Neurosity and the Unicorn.
Do you know how much this Unicorn Black runs for?
I think it's Sorry.
Yeah, I think it's about 700 too, 700 or 800.
Yeah, it's about 1,000, and then the
Oh.
Python interface is 500. And I have no idea what the licensing limitations are for it or whatever, but yeah, it's about $1,000 for the neoprene with sensors, and then it's like 500 for the Python API. And I don't know whether the Python API is necessary.
That's worse than Emotive.
Yeah, and I'm like, and I'm trying to figure. Well, Emotive charges you by the minute, which is on another level.
That's cruel.
Yeah, you get 6 5-minute recordings a day, which I'm like, not even a 30-minute chunk. 6 5-minute chunks is just bizarre to me. Anyway, sorry. But yeah, I'm fascinated. I don't know how they're charging $500 for a Python interface. If you have multiple devices, do you just buy it once? I don't know. But I was looking at it. They have like kits for schools for 20 grand. Buy like 6 devices. And some others. I'm like, I guess this is how you get paid.
I just posted the Stefan Debner paper that has the C strip of electrodes behind the ear, and I forget if he's there's a company that makes it. So at God, when was is Icon the one that's every 2 years? Anyway, I think it was Icon in Amsterdam, where at the industry, one of the industry booths, they had these flex printed sensor arrays that are very cool. I mean, for the limited ROI that they're designed for, but you could put, and then with these glasses, it's glasses are something that people can wear for a long time, and you can still have, your stimulus presentation and things like that all focused in the glasses, and all, incorporated in the, like you see with that previous link in terms of in the, what do you call the part of the glasses that goes above your ear?
The frame?
Is that the frame? Okay, the frame.
Maybe.
The wings, like. Anyway, by the way, he also has a new paper. I mean, he's got another paper that's I saw recently, which with electrodes. Oh yeah. So, and then I assume everybody saw this in terms of. Which I probably. Yeah. Okay. So they've got a preprint available for it.
So is there a device available for this ear thing?
Yeah, well, so Icon, which I want to say was like 2018, there was certainly a company and selling, like trying to commercialize this, and they knew Stefan, or they came out of his lab, or they were in the BioE department, and I forget what their connection was, but like, yeah, they were definitely selling that. Whether they're still around, I'm not 100% sure, but get in touch with Stefan and find out. These C grids, as they're calling them here, that's what I thought would be great for unobtrusive recordings where you're doing like just auditory steady state,
Right. Yeah.
and
Exactly.
other kind of paradigms, and you could do that for long periods of time randomly, right?
Yep.
So like somebody's wearing that, and then suddenly they're getting tones, and you're doing like a mismatch negativity, right? It doesn't matter what they're doing.
Yeah, that's exactly what I've been thinking about. I mean, not down to the level of the device design.
Sure.
But yeah, it'd be interesting to know if like they sell these things.
Sure.
And if they're cheap.
Sure.
Or if they have.
So as I remember it, like they were sold separately, and I would want to basically I would want to buy their electrodes and use like a Dimitri board to collect the data.
Okay.
But do what they did, where it's just like have Dimitri's thing basically hanging off your belt, right? And a simple like audio cable, like cable connecting them, but it having all 16 channels, or something that's a little less ribbonish, but certainly Bernard's just doing ribbon cable, right? But a pretty still a pretty thin ribbon cable. You remember some of his pictures? So Bernard Marcus, who like I think he showed us some pictures. He stayed up very, very late in the Netherlands to show us some pictures.
Yeah. Right. And he was using was he using the free EEG, or was he talking?
Yeah. No, he was using OpenBCI,
right?
And he was the one that was actually funding some of Dimitri's work to get new boards out, the free EEG boards, and so they've got 2 boards coming, and yeah, like I got something from Dimitri yesterday. Anyway, it was like a ship. He sent me like the ship date, and he was very excited. I mean, I hope that's.
Do they have more of these boards for sale? Do you know, or because they did like?
Yeah. So like yes. I mean, in the sense that like, so one, all Dimitri's work is open source, right? So you can kind of do what you want. But I like AJ's already said he'd buy a board. There's a researcher in Italy that got in touch via Slack that would purchase one too, and and I'm going to get one for Andre, for Andre Parfenoff, the BrainFlow developer, so that hopefully we'll get BrainFlow support from the same, with this hardware too, and because I mean. Yeah. So
I have 2 questions about free EEG. One is, why is it called free? And the second is like, what's the difference exactly between, in terms of features or whatever, from OpenBCI boards?
Right. So a couple things. So one is called free EEG because Dimitri is a great advocate of free and open source development of all sorts. So
but he's selling them.
What's that?
He's selling them, right? So
no. He makes all the plans available on GitHub. So Bernard made a fabrication project out of that, and is getting it built by Seed Studio.
Yeah, wasn't originally he open sourced everything, and if someone wanted one, he would hand solder the whole
He
thing.
would hand solder the thing.
Yeah, and so at that point, I remember someone was like, "Let's just arrange a group buy and get it made."
Yeah.
But yeah,
So
you know what the price range on that is?
yeah, it's like so currently, I mean, when we're talking about like less than 5, it's like $250. And you know,
possible,
Bernard,
I'd like to get on board with this.
yeah, and Bernard's super happy to, you know, share everything that he's done. Like he's been trying to do kind of what you know, Josh has done, in the sense of like he's got, say, like 50 customers ready for a board, right? I mean, ready for a board plus electrodes for a particular application, which in Bernard's case is similar to Josh's, in that focused on neurofeedback, in particular for a particular meditation group. And so, but Bernard's looking at it as like, hey, these 50 customers will, you know, offset my costs. And, you know, Bernard's put in a good amount of money in terms of, you know, not significant, but enough money that like he would love to get that back. And, you know, selling 50 units would get him to a better price point with Seed Studio, and, you know, et cetera, right? And isn't that what JD also targeted? Like he was only hoping for 50 blueberries, I think. And it like with 50, like, you know, he, as long as he made his money back and it covered all the engineering time, he was quite happy. There was just some issue where I think with like COVID or something, some parts, you know, jumped up like 20. No, it was the Bluetooth license. Yeah, that was it. Do you remember him talking about this? He said now, you know, he had to spend 2,000, and now he's got to spend 8,000 for the Bluetooth license. Something, you know, quite significant when you're only talking about 50 units, and, you know, 50K, I think, was his Kickstarter target. I have not seen this, Jason.
So I saw this thing a long time ago, and it's meant for like professional sports, but now they're actually selling it directly, it looks like. And the prices like come down a lot, because I remember reading about this years ago, and they were saying it would be like some ridiculous amount, like thousands of dollars for each time you're going to use this. And then like during a sports game, they would just slap it on like an athlete, see if they had a concussion, and let's throw this thing in the garbage. But like I'm wondering about this thing now, because it's like $109 for one of these. They still call it like a disposable item, but
disposable.
I really don't think, you know, it's gonna, you know, die on you after one use. I feel like this could probably be used many, many times.
Oh, wow. Okay. So I thought that they meant that it came in 10 pieces, but you're saying that you get 10 caps.
You get 10 caps for $1,000, or one cap for $109. But the caveat looks like is if you want to use it, you buy their whatever other product. It's cost $6,500 US. But I mean, do you need that? Can you reverse engineer that thing and then have like
looks
a
like
really cheap device?
You need to reverse engineer the $300 cable as well.
Well, that just looks like a regular like serial cable of some sort.
It does, right? That's something you can get.
That's a pretty basic cable, I think.
I mean, we've made these, like, how many times though have I needed that though, like a breakout, you know, this kind of breakout cable.
Which project is this?
brain.
This is like a commercial device
Oh, okay.
for sports concussions.
Oh, okay.
But they just started selling it like direct to consumers. So
Is Michael on tonight? I know he's particularly interested in concussion.
There's a company who I've been talking to. They're based in somewhere in Ontario. I think I'm blanking on the name, but the kind of main scientist on it, I think he's a McMaster. And anyway, they do ERPs for recovery, and it's an interesting kind of business model. So basically, they have a suite of, as far as I understand, they have like a suite of ERP, protocols, and they track basically changes in your ERP responses over some period. I guess the idea is like after you've had a concussion or during a rehab set, like course of therapy or something, and they use essentially the changes in your ERPs probably are your latencies improving, getting faster as an index of improvement, and they give you like reports based on assessment of your Vox Neuro. There we go. I think those are the guys. And the blob that they have, it's kind of as you'd expect. It's like a objective cognitive rehabilitation, brain-based cognitive rehabilitation diagnostic tool. But it's an interesting idea because I think technology-wise they're just using straight up standard like commercial EEG system, like no special hardware and probably no special software. It's just what they're doing with their measurements. But the most interesting thing maybe is that the way that they kind of slot in business model wise in the way things work. It's basically like a gap in the system. This kind of there's a lot of interest from essentially like the entire general public in rehab kind of solutions around concussion, and the medical science on this is extremely thin, and the actual kind of available medical off your insurance or off the Ontario like provincial health kind of thing, like there's not much that's covered, and people want to get some some medical biological therapy support for when they think they've had a bad concussion or when they think they're trying to kind of recover from taking a bad knock. So there's these private clinics. There's loads of them around, and they do various things that I don't know what level of like regulation or unification of. My impression is like their services are quite heterogeneous and potentially esoteric, but those clinics are interested in this kind of technology, and it's completely outside of the healthcare system, or at least it's largely outside of the healthcare system. Just these private clinics that do these rehab, courses, and this company's coming in and they're basically, supplying their assessment methodology, essentially like partnering with clinics that are doing some kind of rehab, right? So the clinics do the rehab, and they have different approaches to what their kind of special way of doing rehab is. And this EEG company basically coming in and doing monitoring for them, monitoring with ERPs and supplying reports and stuff. And yeah, it's just really interesting, avenue that someone kind of scoped out for using like really just straight up like standard measures. Like there's no technical innovation, there's no hardware innovation, there's no software innovation. It's just stuff we can do with EEG, ERPs, measure those, and then the other thing that's kind of smart about what they're doing is they're not saying they're diagnosing concussion, right? Because you can't do that.
Yeah.
But they're saying they're tracking changes in some brain measures as a function of weeks or months in a rehab therapy program. So they're just saying we're seeing changes. They're not saying this is a biomarker, because finding biomarkers and saying that you've got a biomarker, like, that's big business and that's hard. But just tracking changes, like, yeah, of course you can do that.
Sure.
Yeah, this was something that came up in one of the conferences that we went to, and it's something that we've been exploring as well, because it kind of finds a nice middle ground. People get very skeptical on brain training as a sort of generalized claim. I mean, you look at the way lumosity's been treated and whatever, and people don't like it. It's a very uncomfortable topic. But if you narrow the scope and you say we're going to help people that have potentially suffered a traumatic brain injury measure and track their progress towards recovery, it just really changes the conversation, because you're no longer the person making the claims like, I know what's wrong with them and I know when it's fixed, and more like you're providing a tool for them to sort of track their progress on that. So it's been very, very interesting. I do think it's very heterogeneous. And in addition, I personally would love to talk to anybody that's used or knows anyone that has used these services, because I would love to get a feel from like the patient side of what they thought the efficacy was. But yeah, that approach that John just articulated is something that's been very, very interesting to us. And we were really looking at, can we come up with generalized metrics for places that do brain injury, recovery.
Yeah, I might be working on a project like this.
Cool.
I've been talking for months with Ben Tam and some people he knows about this. Yeah, it's very interesting. Read about ERP. We're trying to do that.
We're not hearing you.
Your mic's muffled.
Oh, okay. We said we've been just reading into all that, and like event-related potentials, and we're definitely wary of what methods, like if we develop software for this, like we're definitely wary of what methods we should be using. I don't know. It's just interesting. I can show you guys some boards I've been working on if you're curious.
If it's something you're comfortable sharing, yeah, I'd love to take a look.
This is all open source, man. Okay, let me.
Yeah, please, Josh.
Share. Can you see it? Oh, hold on.
I saw something for a second.
Okay, now.
Keep in mind that this is published on YouTube. Everything you share is published on YouTube.
That's okay. Everything I do is public. So.
Right.
But
can you see
thank
it?
you, Micah. Yeah, that's good.
Okay, cool. Here we go.
Yeah.
So this is a modified version of the prototype I did for JD. I actually finally got it working, and it worked fine, other than I had forgot to connect a ground wire in one place, so my light sensors were giving me more crap than good signal. But I ended up moving it over, so now I'm just going to have 2 light sensors at the spacing. And then this is a flex material, so I'm able to fold that LED over and use it just as like a reflectance pulse oximeter as well. And then the other one I'm working on is, after talking to Dimitri a whole bunch, I wanted to give a shot at making an 87771 board. And then, so what I designed is like this little, it's like a little chiplet. So it'll have the 8-channel ADC on it, and I did everything I could to find all these low noise parts, and it's got like a isolated DC to DC. So, hopefully it's safe, right? And then it's just going to be like a generic little breakout board, so you can use this thing. And I found out all the code libraries are free thanks to Analog Devices. So all I have to do is write a little Arduino library for it, and I'm set. So these are in production right now, so I can test them. I found out that this board, just 3 of them cost me, $180, real cheap. I tried to minimize the cost on some of these other parts, because the ones they recommended or recommend, and the data sheets are usually pretty expensive and like made by the manufacturers of these other boards, or of like the analog to digital converter chips.
If I could just say one thing that I didn't quite finish with John. I mean, John, you asked about free EEG 32. This is the chip that this is what sets Dimitri's board apart from OpenBCI's current chipset, and that was what got AJ excited, in the sense that, like, hey, we wanted to use that chip, and maybe their like Notion 2 is going to use it, but that was why he was interested. Was that like it's kind of a more advanced chipset that's doing the A to D, right?
Yeah, it's like a low level RF ADC. I mean, it's got tons of little things in it to improve the signal acquisition, and it's, you know, of course it's sigma delta.
Yeah.
Like there's like some slightly more expensive parts that have some really impressive things, but this is the one that has like the best price. It's like 128,000 samples per second per channel simultaneously. So it's good.
So it's just like like a variety of improvements in quality and more channels. Is that a reasonable summary?
Well, certainly, you know, like what Dimitri and I have always been talking about is what he can do in terms of ganging his boards together and using an interconnect bus and getting us to, you know, 256 channels, right? And so, you know, getting to 256 channels is potentially just like, how many boards do you want to stack? But it also comes down to, and then what can you still sample on all of those channels and get them off the you know, so like what sampling rates, you know, we would like to be able to do all channels at say 8 kilohertz, and also be able to get that off, which is why, you know, you'll need to add like an Ethernet port or something like that. In terms of
8 kilohertz.
Yeah, 8 kilohertz on 256 channels.
You don't need to sample 8 kilohertz.
You don't, but the question was, what would you need to, you know? So I was setting that just because that's what you would need if you wanted to record in a magnet, right? So you need extra fast acquisition to be able to get the artifacts, the magnet artifacts. And so, you know, so that's what a lot of manufacturers use as like, that's their super fast acquisition.
While we're on the topic of sampling, can I just ask a real quick question, slightly on a tangent? When I was looking at the Unicorn Black, one of their big features is the 4,000 times oversampling that they claim they do. I messed around with sampling rates on EEG a lot, and I've discovered, you know, like most of you really don't need a high sample rate to do anything with EEG. It's just fine. And the higher the sample rate, you don't get anything else other than more frequencies, which you don't really need. So has anybody used oversampling to improve EEG signal quality? Is that like marketing fluff, or do you think there's anything to it?
That's standard, actually. I mean, it's like, well, we have all this juice, we might as well use it, because the power, like, it's really not that much more power.
Right.
Yeah.
Well, technically, you can use it for EMG or heart rate variability. It's not EEG, right? But because the brain rhythms are pretty sluggish on the cortex. But if you want to do some bipolar recordings on some muscle here and there, and do some, you know, it's technically still a BCI,
Mm-hmm.
because it's, you know, it's peripheral, you know, neuronal activity. And EMG requires slightly higher, the motor unit action potentials, the averages,
Mm-hmm.
have a median frequency of around 500,000 hertz.
Mm-hmm.
Other than that, I'm thinking about what Morgan said about the artifacts. I cannot think about any application of the under 80, what is it, kilo samples per second, but because then you have to deliver those samples somewhere, right? You don't want to throw them away. So where you know, the super powerful interface, right?
Right.
But it's not as if oversampling the EEG data would somehow improve the signal the way they seem to be implying, or do you think that that is valid?
Oh, resampling the EEG, no, other than, aligning to some other kind of,
Right.
LSL, layer.
Right,
because
right.
you
That
want
we've
it,
done. Right. If you need to find a common clock for different
yeah,
devices that have different sample rates, sure. Right.
There
Yeah.
tends to be, like with Wi-Fi or electrical noise, it tends to produce high frequency noise that oversampling can wipe out.
Okay.
And then I forget. Well, yeah, like what he was saying about heart rate and EMG as well. I mean, those are all basically the same sensors that we use for EEG. So you can actually, there's a lot of math they do, right, to try to eliminate different sources of signal.
So there's also, just to consider, if you're using a sigma delta, it's actually sampling at one fixed frequency, which is typically the highest frequency rate that the sigma delta ADC is advertising. And then what it's doing is an internal averaging. The question is, are you going to be doing this better than what they're going to be doing on die on the ADC? And are you going to respect the noise-free bits that they estimate, because they go down to half a bit perhaps is what they lose in the averaging? Are you going to do better than that? The answer is probably not. And so if you are going to be if you're going to be trying to oversample, specifically at the lowest level, like you should give some healthy oversampling that gives you a good software buffer and software averaging that you want to do. But for example, if you have a 32,000 sample ADC, you're running it at 8,000 samples per second. It's doing the averaging for you, and both in the noise regime and the frequency regime and the phase regime, it's measuring everything basically on an averaging scheme, and that's a function of the sigma delta.
Okay, cool.
So if you look at any of them, they usually provide a table with estimated noise-free bits. And so that's where you should be judging. If you can do better than that after you've sampled and after you've done a true noise analysis of your full pipeline, then you can consider if it's worth it. But my estimation every time I've used these devices is it's better to let the die do it for you. It's just my opinion on that.
Yeah, and then I don't know the 777X, but the ADS 1299 had a figure of noise that was, increasing exponentially with the sampling rate.
Yeah, that's typical. I mean, what the sigma? I don't know the 1299. I'm familiar with other families, but sigma delta sampling is very very powerful in some regards, but it's less flexible in terms of like you are sampling at a fixed frequency. There's a fixed decimation rate that the thing is ticking, and that's fundamentally what sets your noise. And I don't want to use that in quotes because there's many factors and parameters and subcomponents of the noise that you have to consider. But you take all that together and you get the estimated number of noise-free bits that you get out of a certain bit ADC, and from there you can do certain calculations to see what that means in real signal. Then you still have to consider your analog front end, and if all of that ends up being, then you make a determination where to put the software averaging, and at what level do you do software averaging or other kind of averaging scheme, however you want to call it, processing, pre-processing. But it's a complicated question, and really a lot of it comes down to doing real world tests of what is your actual pipeline noise and where to set the trade-off between ADC averaging and software averaging.
That's
Cool.
great. Oh, sorry.
So sorry, I had a specific question on that, if you allow. One brief question, Andre. So what is the rule of thumb if you look at the highest sampling frequency of a chip, like let's say the 777X, claiming 120 or 160, I forgot, K sample per second? What is the rule of thumb for, a safe, intermediate sampling frequency, so that you can trust, the noise-free bits? Should I sample a half of that?
No, I mean I don't know what a rule of thumb would be. I think the question is, what is your application sample rate requirement, and then you go from there. If the application sample rate and noise requirements are identified, then you go to the ADC tables and see if you hit those requirements with the ADC, given the configuration you're going to have to put it in. That's an exercise that's quite complicated to do across a large amount of ADCs, and there's a lot of subtleties you won't find out until you start working with them. And anyone who's worked with an ADC knows that they can be really bizarre sometimes. But so the answer is you start with the application requirement and then you trust the data sheet that's provided. I'd say a factor of 2 is probably reasonable, just because you have the ability to change the sample rate as your needs require and still be within the operating regime of the device.
Thank you.
So it's a real challenge problem. Like, I mean, fundamentally, anyone who deals with any kind of high fidelity sampling is going to be asking these exact same questions. So they're really, really good questions. I have experience in that in my domain, but certainly EEG is a very different beast. And so that was just my kind of contribution to this.
Well, another thing is, like, at least in my experience, the power noise is going to get you before you ever hit the sort of limits of your ADC.
Yeah, certainly. And that goes to front end analog front end considerations. Those are certainly not trivial. Also, if you're talking about like AC noise, like for example, certain ADS TI chips, analog device chips, they have 50 hertz and 60 hertz notches on board, which probably would work better than anything you do on your own. But yeah, so all of these things, like if you're fundamentally have 8 bits of analog noise, 8 bits of analog resolution based on your front end and all of that, then yeah, you're also oversampling in terms of bitness if you're doing a 24-bit or 16-bit even ADC.
I have a probably very naive question, but why is there no ADC that has a resolution bigger than 24 bits?
There definitely are. You're asking for more cost, though.
Yeah, what kind of application use 48 or 96 bits?
I don't even know if, like, I think all I've seen is a 64-bit ADC that was like $50,000 or something. From what I was reading about it, they were doing like some kind of upscaling to get to it.
So another way to consider the question from a physics point of view is a 24-bit ADC is 10 parts per billion in terms of resolution and change of signals, so basically sensitivity versus full scale. So you start talking about what 32-bit, where you're getting into parts per trillion. So that dynamic range exceeds, we'll consider, let's say, camera sensors or something like that. Take a look at what their dynamic range are, and you're going to see that you're kind of hitting this kind of physical limit. Maybe you can say with the given technology, it comes down to an energy max amount of energy that you can derive, without having the whole thing explode in terms of noise. But you're hitting that limitation. That's why 24-bit. And also, who's going to pay for it really comes down to is it's not us who's buying 50 boards at a time. It's somebody who's going to be out there buying 10,000 or 100,000 boards. And if there's not really that kind of customer, then you're not going to see that product.
That's interesting because it's all assuming that at some point you're cutting your DC and you're using your dynamic range based on your microvolts in terms of EEG, for example. But there are other applications where you want to really measure the DC component. So for that application and to measure DC and microvolts components at the same time, you would need a bigger dynamic range and also bigger resolution.
Yeah, if your signal dynamic range is really small, then you blow it up, and that's would be handled. Not all. I wouldn't say the best way to do it, but a very straightforward way to do it is on the analog front end. You want to measure 3-volt DC. You want to measure, let's say, 5 millivolt offset. From that, you subtract away the 3-volt, and then you blow up the 5 millivolt. And so some ADCs you can do that on board with gain amp, programmable gain. Some, the ways to do it is limitless. And at the end of the day, you have a systems analyst that needs to come in, or somebody knows the system analytics and compute the noise flow and see if you're going to do better one way or another. And at the end of the day, it's probably going to result in you trying to do real world tests if you're trying to figure out on that really minute level which one's better. And for an academic publication, yeah, absolutely, you'd have to do that. For some of this other stuff, maybe not.
So if I put out an agenda each week. we never really follow it. But if people wanted to, I've got so this week was the start of excuse me. This week was the start of Neuromatch, and which is a computational cognitive neuroscience unconference, and the certainly there's a lot of great talks and a lot of good research presentations. But they also had an industry section where they cover, particular companies also did a little pitch of their products or technology. And I was going to cover some of those, or I was going to just drop in a few links to some of the some of those companies that presented. And certainly one, this is a particular neuromarketing company, and I'd love if Alex wouldn't mind chiming in with the iMotion stuff that I also shared. But one of the things that Mindtrace talked about was that they're getting, they're a neuromarketing company, but they're getting so much interest in their technology because a lot of researchers are thinking that they're not going to be able to get people back into the lab anytime soon, and they want to do roll out experiments at home. And these are the, I'm assuming that these are web enabled. I know that they're doing, Microsoft Cognitive Services does this kind of, emotion detection too. But the main thing being that, can you take somebody's webcam and while they're, getting a, say, JavaScript experiment, you can record the, oh, hey, hi, Kyle. You can also record their, get their emotional reactions, as well as potentially, some devices. And I'm not, how you doing? And you dropped in a webcam.
I got asked by this artist neighbor who wants to measure people's physiology when they're at his exhibit to do something like this.
And so are you using one of these cloud services to label the video?
No, that'd be nice. No, I'm just doodling around for now.
Oh, okay.
But you can just measure the luminance of the face.
Are you getting, can you get heart rate?
Yeah.
Cool.
Yeah, but I guess you could do the emotion recognition and stuff too.
Microsoft's been selling this for a long time, and I've asked for some demonstration of why they think that they're getting this, why they think they're getting, and at least a couple of years ago, it was always funny. People would take that and they would run Microsoft's labeling on video of that person's country's, president or premier giving a speech, and you'd get this, emotional breakdown of, and it was done in a lighthearted way, but I think it did expose quite a few, valid questions about the.
Yeah, we were thinking of doing a funny, just the heart rate. I think emotion is better. The eye tracking, I think like a decade ago, I was using an eye tracking webcam on my laptop.
Yeah.
As like my workflow for a while, but that didn't last.
When you say workflow, you mean to run experiments?
No, like part of me coding was like it was tracking my eyes, and I was doing some sort of interface with the webcam eye tracking.
Gotcha. Well, we've talked about I forget if it's called Gaze. Is it Gaze Pi? I mean, there's the eye tracking researcher who he wrote the book, Python for Experimental Psychologists.
Yeah.
I'm blanking on his name. He's a Dutch guy who did his DPhil in Oxford.
I'm so close.
It's like Edward, but it's not.
Edwin Dalmayer.
Yeah, thank you. I mean, the cameras are quite good, especially recent ones.
Yeah, I think that the getting it into the browsers the harder part. Like you can do this stuff in MATLAB for a decade, but getting it all working so that you can deliver it to some. He wants to deliver his art installation to people's houses. Like they can't come to his art installation, so he has to send it to them.
Yeah. Right. Well, so I don't know, Alex, if you've got do you have the link that I sent you, the iMotions?
Yes.
Is he trying to?
I'm on my cell phone, by the way. Can you guys hear me okay?
Yes.
Okay, cool. Yeah, the two companies that seem to do this in the sort of commercial space are Affectiva and iMotions. So Affectiva is kind of like really more SDK driven. They will let you do an app for your smartphone, for your PC, for your Mac, whatever. And they basically just give you they draw out like 16 characteristics or emotions that they feel that you're experiencing it, and then they'll rate it from 0 to 1. Similar thing with iMotions. I think it's a very similar use case, but I will say it's kind of interesting. When I went to the XTech conference, they have the iMotions set up and pointing in the crowd. So as you walk by their booth and you look at this monitor that they have set up, because of course, as you walk past the booths, you look at the displays to see what they've got. It shows you walking past the booth with your face and whatever emotion you have on your face at that time. And it's actually a pretty trippy thing because you're not really expecting to interact with it, but you walk by it and then you're like, wait a minute, I just got analyzed. And it has this kind of like, it really catches your attention. But yeah, those are sort of the two that seem to do it. And they have a very similar method, which is you have some kind of device that looks at the edge of your mouth and eye shape and ratio and eyebrows and all that other stuff. And then it breaks that down into how confident it is that you're experiencing one of those emotions 0 to 1.
Yeah, well, I dropped in the iMotions, so this is their super recent, press release, or I don't know, they call it blog, but okay.
Oh, wow. Right. No, that's a great point. For instance, what if a TV was cheaper if it happened to have a built-in webcam that you couldn't turn off because they could use it to see how you're responding to the media? It raises a lot of questions.
It's
$30,000.
It's
$30,000. The lease is $7,000 if you lease them for a year.
It's most likely that this tech is at your bank already and at the airport and maybe even the grocery store. They, yeah, at our new hockey arena, I noticed that facing the doors where everyone comes out, they've installed like a very high-powered camera to get everyone's face on video as they leave the game to see how much fun they had. Oh yeah, on Splash Mountain. They're getting
Spot on.
So Seed Studio sells for $6,000 a for your office or factory, basically a camera setup that takes everybody's temperature and verifies of the picture against the database of employees as you walk through the door.
I could do that. That's a great company.
Huh?
Just need to find the customer.
What did you say that was? Foxconn?
Seed Studio. But so that was, I mean, I did want to point out these companies and at least, you know, that this was raised at Neuromatch too, and that like everybody's going to be doing experiments from home now, and you know, prepare accordingly.
Did they have a good solution?
Well, you know, so Mindtrace that did I I post that in there. So these guys, somebody from Mindtrace, presented, and certainly, used their time to raise that, to start that discussion.
Right.
and one of the things that they were saying was that, like, they were neuromarketing. I think they were also saying that they started up pretty recently, and thought, like, oh no, this could be, this is going to be bad for us. And then they were like, well, then everybody was actually asking them about, being able to run experiments. More like researchers became interested than just companies for neuromarketing and advertising purposes.
Yeah.
And I think it kind of brings around this tension of, like, conferences where people want to be there and want to, like, watch the material, versus a lot of companies know full well that people aren't really watching their webinar. They just kind of tune in or whatever. So a lot of these tools were developed to kind of give you an idea of, are people watching your app? It'll tell you stuff like, 40% of your attendees have the presentation minimized, so, or they're not, actually having the tab in the foreground. And it creates this really interesting tension between, some conferences where you want the presenter to have the tools to know how much the attendees were watching, versus, like, yeah, it shouldn't, it's a very weird area.
So kind of getting at this, so I just posted another link, which is this brain attach or biotactical gameware.
I want
it. Like, I don't know
amazing.
what it does, but I want it. Yeah, I like.
It looks awesome as well.
For you, I like the quote. For you, gaming is so much more than just a way to kill time. Yeah, kill the time. Anyway, it's again just like I was saying with Joe's link to, I forget what that company was that made the glasses that I was showing earlier, but just, that the glasses are a great form factor. and as we know from, Toby makes glasses. I mean, SMI used to. Who else is making? I mean, this is doing more than just eye tracking.
What is this doing? This is
So they're doing some sort of. I mean, they're doing something like
data.
Notion
data, very clear. EEG data. Okay.
Yeah.
This is, they got some funding from the EU at the bottom. I find that interesting.
We had 12 years of deep analysis to understand and learn how to work with the EEG signal in order to get the highest quality. Now we are proving this quality directly to you. Okay. That's nice.
The device looks like a Klingon muse.
Yeah.
It really does. If you're going to make a piece of gaming gear, it's got to look like a piece of gaming gear, apparently.
I like it. I love this feature. Like, got the EEG hardware.
So I did not. Oh, they haven't. So there's just way too much going on this week. So I didn't actually catch their pitch, and I don't know what the waitlist time is, but I assume it's this year. For those looking for your Klingon accessories.
So what section of Neuromatch were these folks talking?
So this was industry talks. Oh, excuse me. So it was, it was yesterday afternoon.
Were they just giving little quick presentations?
Yeah. So I mean, I caught the mind trace, and then, well, MIT Press also. I mean, like, it wasn't just tech, it was like anybody who's willing to be a sponsor, basically, right? And so MIT Press talked about some cool books, and then
Books, like physical books that they're sending around?
yeah, well, they were kind of like, they were pitching like for particular titles that are coming out, and
Nice.
they talked about their long history of,
Books.
printing science books.
Cool. How's the conference more generally? Have you been attending?
Yeah, I mean, as much. So yesterday it became weird because the non-invasive brain stimulation workshop started, which was Wednesday and today. So I was like, not catching everything, and but really wanted to catch all the SimNibs talks, and that was something we can talk about a little bit. I had, there was some cool, I mean, this isn't going to be, it was cool monitor stuff that's like,
Yeah, we use those in the lab there.
okay. Yeah.
They're the best.
And I mean, so what would you potentially get from those that you couldn't get from an OLED? Well, I guess it's frame rates.
No, it's not. I don't know about the newest of OLEDs, but the way I understand it is that at any given refresh, the pixel refresh to refresh delay isn't entirely predictable in an LED display. I guess the LEDs don't raster on in a nice order like we want them to. They come on as fast as they can, and so one might not necessarily flicker on 60 times a second exactly as we think we want it to do. So those machines you saw, they like create that artificially by using a tractor beam, kind of like they shine a little beam that runs across and up and down.
Yeah.
That simulates a raster. But I think the idea is that you can't predict the onset time of an individual pixel at a location on the display.
Yeah, and the other thing is that the latency is different. So we did some pretty elaborate testing with LEDs to try to get a better sense of it, because it was something we were going to be dealing with most of the time, because most of the people that we work with are using an LED screen rather than an OLED. So for instance, the one that we were using has a 15 millisecond refresh rate, but the 15 milliseconds is at the bottom of the screen because it starts drawing at the top. So at the top of the screen, your refresh is like 1 to 5 milliseconds, and at the bottom it's 15. So stuff like that comes into play. OLEDs are just much more well-behaved in terms of controlling the pixels, controlling the rendering time, and having it be more uniform. So I think there's a bunch of, it sort of gets into the, do you need to operate at the 20 millisecond scale type of thing? But if you do, then OLEDs are massively advantageous.
Yeah, sorry, that's really good information. And we were even talking about the benefit over like trying to find an old CRT monitor, which is what a lot of research labs do, or to use
they do, right.
one of these VPIX displays, which tries to simulate that.
Yes, and the UC Berkeley lab that we were talking to, they use an old CRT for exactly that reason. It's a 1 millisecond screen draw latency, but the way that the CRT guns work is quite different from the way LEDs render things. So yeah, when you're using an old CRT, one of the advantages is that within 1 millisecond, all the pixels will be updated to sort of their current values. Whereas with those LEDs, that 15 millisecond delay, top to bottom drawing definitely comes into it.
Yeah, but I like we've been using just LEDs from the boards, which is a nice kind of
Yeah.
way to avoid all these problems.
Yeah. Well, I've got a 17-inch CRT downstairs.
Cool.
Yeah, it matches one in Gaslab. Back up. Yeah.
Yeah, in general, they're kind of getting old, and I think there's like a trade-off now because the ones you find are like clunky, and so it's like, okay, it makes a funny buzz, but it does raster nicely. But I think that if I usually just look if they're 120 hertz or not, if I'm looking at the back.
You can get pretty elaborate with it, I believe. I started going down the CRT rat hole a while back, and there's arrangements with single gun units, multiple gun units. When I say guns, I mean they're firing electrons at the screen to get the stuff to activate. So there is probably some architectures that are more beneficial than others, but we can look into that, or I can help you kind of get a sense. We can take a look at the hardware that you have, which models, and I can see whether any of them have different back-end hardware.
So
in the gaming community, is it understood that a CRT does give you better latency?
Oh, wow. That is such a fascinating topic of conversation. Some of the really hardcore gamers used to use CRTs for that reason. But the real issue that you run into today is that what you can do is you can get panels that run at much higher clock rates than CRTs. So there's really no CRT that's going to go above, like, let's say 120 hertz refresh, which you just brought up. But they have a lot of issues going past 60 because in a weird way, the advantages of the guns turn out to be disadvantages at high frame rates. So what most of the really hardcore gamers do now is they'll get like a VA panel, which is a very specific kind of LCD panel, which lets you get your latencies down to about 1 millisecond, pixel to pixel, green to green type of thing. And it lets you run all the way up to 240 hertz. So sorry. Right. Right. Mm-hmm. Right. 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 Mm-hmm. Right. Mm-hmm. Right. Mm-hmm.
Cool.
Right. 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 Right.
And EEG, we got to push the gaming community to develop EEG so that that same energy gets applied.
Yes, absolutely.
And optical sensors too.
Yeah. Right.
Yeah.
Right.
And brain
then,
stimulation as well.
and then yeah, and just to wrap up the discussion. So the big advantage of having the high frame rates is the chunks of time between frames. So when you have a 60 frame per second game, the user can only really interact with the rendered frames every 16 milliseconds. So the more you can raise that frame rate, the lower the gap, the more responsive the whole experience. And yeah, as you can see, the gaming industry has gone quite down the rat hole and has found various solutions to the problem of fixed panel displays. Yes.
I mean, certainly, they've definitely got a lot of they got a lot of vision and perceptual science researchers working now on this. Than before Facebook owned Oculus.
Yeah, one of my classmates went to work for Oculus.
Yeah, I mean, I see Facebook Reality Labs positions a lot. Drawing in former researchers. So let me just drop in a few more links and well, one, just wanted to, as always, give John a chance to give us any updates on EEG notebooks.
No major updates. Right now I'm working on the documentation stuff still. you know, the new site is live, as in it's there on GH pages, but it's not linked to anywhere, so it's kind of hidden. I am looking to switch the new refactor over to the main master soon. It's not quite ready yet, but you know, I want to kind of tie up the loose ends, and then that'll probably happen at some point. So then there'll be like a new set of folders and all of that, and a link saying, if this confuses you, then here's a link to a previous commit where things looked like they used to, or an old branch. Actually, I should do it on an old branch. Yeah, no major updates. I mean, one thing that's related though is we're doing a call with OpenBCI guys tomorrow, which, you know, came out of the discussion last week, which was a nice, fairly serendipitous kind of thing that came up. So we'll talk tomorrow about this summer challenge idea that's floated around.
Good.
And the plan, as we described, is to, in the first instance, use Jaden's OpenBCI modified EEG notebooks and come up with a kind of minimal set of experiments that we want people to acquire data on, and then we need to kind of challenge around some classification problem for some evoke potential data.
Yeah.
So more on that after the discussion tomorrow. Next week, give you guys an update, and you know, there'll be probably some delegation and some kind of looking for contributors to bits and bobs of that, because there are a few different arms of this, right? There's going to be the challenge, there's going to be a little bit of just development work on the paradigms, there's going to be general debugging and trying stuff out, and then some deployment, hopefully as soon as possible, but you know, it will take a few months, I think, to get ready to roll.
Okay. Well, I mean, that's great. I mean, you know, I wasn't expecting, you know, a lot that has happened, but like, if there's anything that you need, you know, just when you know more, let us know what people can be helping with. I mean, we've talked about this, like we need more people in all aspects of this, but to get familiar where they can be contributing, and, you know, not leaving this all to you, but getting, you know, certainly like getting their support behind this data collection would be awesome in terms of increasing the number of people who are willing to, you know, go to the extra steps of downloading the software, getting it configured, plus, you know, being able to send data back and so I don't know if that open consent stuff that
was great. Yeah, thanks for sending that. I'd actually seen that a long time ago, but it, you know, it hadn't occurred to me when we've been talking about these things recently. So I need to think about if we can make use of that. But thanks for pointing that out.
Yeah, no, I mean, it's cool. You know, obviously, I mean, I you know, that's from Yarrick and you know, his open science, or I forget what, open neuroscience center at Dartmouth. But he was also talking about, you know, I'm basically following him for all the data lab updates. Yeah. So Satra presented Dandy Archive, which was like even more services, you know, so like even more services built on top of Data Lab. And so that was part of the Neurodata Without Borders user meeting. So it's a bit more of like, is mostly like animal electrophys people, but where they're all trying to share data. right? They're trying to share data. They're trying to standardize that data. They're trying to add appropriate metadata so that you can like know what the experiment was, and Satra's technology development is impeccable, and is trying to bring in all software engineering best practices, and so Dandy Archive is even more services that are, I think, would still be useful, but we're still trying to get the experiments together. So as long as that's going, and we'll catch up with it next week. So the SIMNIBS meeting, I posted the for those interested in the kind of computational modeling behind TMS and TES, kind of like, I mean, they'll sometimes call it like dosage modeling, and certainly the kind of things that they will do, in designing an experiment in terms of like, where should I place electrodes, and then certainly a lot of what you see on that agenda was, people refining particular aspects of that in terms of, whether they're doing better, single subject placement, or, dosage, or, I mean, as well as certainly applications that were particularly cool, where they're trying to target, networks as opposed to, so they're trying to, target the saliency network, and so.
So I caught the first few of these yesterday morning.
Cool.
And it's always very super impressive to hear the latest stuff.
Yeah.
So those Apo, they're designing a kind of multi-channel TMS thing that's going to go in the scanner, and they're doing the field modeling for that.
Yeah.
I thought that was pretty impressive, and they're using Dilcher and Co. They're trying to use MRI to measure electrical fields or measure magnetic fields, such as like validate the SIMNIBS models.
Cool.
Right. Yeah. That's particularly cool stuff. I mean, MREIT and MRCDI, as it's sometimes called, current density imaging. It is again, like the kind of stuff that EGI was doing in the late 90s, early 2000s, but specifically for conductivity estimation as opposed to stimulation, right? This was just trying to better understand the skull so that we could get MEG like spatial resolution with a really dense array, and at 1/10 the cost, right? And then that was the idea. But so I mean, Jeff Erickson, who did a lot of that work for EGI, was also burning himself in the scanner back in 2000, where when it wasn't quite there wasn't a lot of literature you could look up and see what you should be, anyway,
burning his brain.
Too high.
Heating.
But some really cool stuff, and I'm blanking on the woman's name, but there's a woman at ASU who's doing some of the best of that, right? I'd say right now. I don't think she presented at this. Where's that? So yeah, I don't see her here.
I wanted to ask Morgan, did you catch the final talk, the one that was like the future of computational modeling?
So Sina Shirinpour's Future of Multi-Scale Modeling?
Yes, that one.
Yes. Yeah,
so
I did.
What was that about? What did that have
Yeah,
in? Did it have some physiology?
Tell us, what's the future?
Yeah. So honestly, from the title, it's hard to know. Well, it was cool. So they were basically combining SimNibs and Neuron.
Right.
And so they were using the extracellular potentials or the extracellular activity features in Neuron, like linking those together with SimNibs models, and also kind of like what's the database, like Neuromorphometrica? Is it like what's the basically it's got like a huge number of cell types.
Neuromorpho.
Neuromorpho, yeah.
And neuroelectro is the one for physiological properties.
And they but in this case, all they need, is it Neuromorpho that just has all the geometry? Yeah, and then you can bring that into Neuron, and then you can basically run cable equation models on that, right? And in what he was adding that I thought was cool was he was specifically modeling calcium channels. And so his lowest level was actually calcium.
So was he modeling plasticity?
I mean, like certainly the talk was very much like how he's doing the multi-scale modeling.
Okay.
Like he I mean, certainly Bettina right before that. So I mean, she's definitely, I mean, she was getting a like spike timing dependent plasticity,
right?
And her talk was also particularly computational, but he was trying to get across like some of the software development that they're doing, and like ended with like, and our code will be available, in soon.
Right. Yeah, I definitely need to check this out. I'm actually doing this kind of stuff, but not very far along with integrating SimNibs with Neuron. It's kind of on the to-do list in the short term, but that includes finding out what everyone else has done on it first. So this is
so. I mean, it was cool, and hopefully, I mean, I'll find out if all these. I mean, hopefully these will all be available on YouTube. Certainly what Axel did, and Axel and Guillaume and is it Ula Ponti, who were presenting the SimNibs. I think they're all in Axel's lab. They actually presented YouTube videos, and so they were like, hey, I'm gonna get this set and I'm gonna play this video. But why they were doing that was that they're going to make these all publicly available, right? Like this is going to be the new training, new SimNibs training material. And I put in a link to the YouTube there. I mean, that's obviously stuff that you can find currently, but I see that they've got a talk up. They've got an MGH talk there, and they've got a NIMH talk up there. And this SimNibs 3.2 is what they were, they weren't always using it, but that's what they were talking about in particular in terms of these TES optimizations. Like it wasn't quite like we're trying to do, it wasn't like they were trying to do temporal interference TES, but certainly like trying to do a better job of more focal multi-channel stimulation. and yeah, and definitely some of the other people were talking about, their particular takes on that. Sometimes they were, like using SimNibs, but using like their own MATLAB code and, with it. And one of the other things that they were rolling out was, I didn't quite understand like necessarily why they focused on this, but like they've got their head recon. So like I still would say like, why not always use FreeSurfer? And it certainly came up in various conversations in the chat that like, if you're not careful, if you think that their head Rico is doing the same thing as FreeSurfer, you will be mistaken, because of course FreeSurfer is doing things in like conform space and stuff like that. So I didn't quite know what pushed them to do that, except maybe to like not require people to use FreeSurfer. But I like it, and we always bring in diffusion, so I think it's just easy to run FreeSurfer plus Tracula, and you get all your diffusion and all your stuff co-registered in particular, in FreeSurfer space, and and move on. Because as far as I could tell, they weren't doing any additional tissue classes. Now they did. Who did this? There was. Sorry, I'm looking for. I saved a particular Zendo reference. Sorry, let's see if I can get it. Anyway, there was a number of cool models that are available on Zendo from Opit's lab, and I will try to find the link. Now those had additional tissue classes, like so, and those included not only they had some basically some geometries that you could play with that had like hippocampal slices, in 2D that you could kind of pretend is in, say, one of Gene's. Because they had a mouse model with like 10 tissue types, and very very detailed, and yeah, sorry, I might have closed that window, but that was the that was certainly one of the big new features that they were talking about, was this head Rico command, which and then at least in my the agenda items that I had, like yesterday I caught Bradley Wojtek giving a talk at UW, obviously remotely, and but he presented the bioarchive paper that I linked in the meetup agenda. I don't know if everybody saw that, but
yeah, it's pretty impressive.
It's an incredible paper. Oh shoot! And give me 1 second. So I know, and I know not everybody came in through Meetup, but one of the reasons that I included a link to the KCNI summer school was that I felt like his paper covered all the things, all the broad set of areas that you guys are covering in the summer school. Because I didn't think I would see such, such sophisticated genomics and yeah, like what he includes and what he talks about is being, a real power of it. Like these are all open data sets that he includes in this. And
do you understand this method? Like I haven't read it in enough detail, but this kind of time scale thing, and then it's like he said that it corresponds to the knee of the 1/f, and like I can't get my head around that. But I didn't really kind of read it enough to justify making a big fuss.
So no, thank you. And so that's the killer. I mean, what I do remember is him talking about the fact that this is in even his early 2015 stuff when he was in GasLab, right? Is that like, and this is what I was working with a student on in terms of we were replicating his stuff with MEG because his original paper was ECOG, right? I mean, at least in the age-related noise, and so we were doing this fitting of like basically high gamma, right? In terms of like, is that line different? But yeah, I mean, I'd love it if his talk was also available on YouTube, but hopefully we could get him to talk about this, in person. Because I mean, certainly like what he gave the motivation for was a lot of sorry, Kyle, you told me her name before. It's like Natalia.
I just read it on Twitter. I don't remember it.
I mean, it's just a lot of syllables. But
Shawaronko.
Yeah, thank you. Yeah, so for those not following Natalie's work, she's posting an almost like daily dynamic plot that demonstrates particular, well, the multiple mechanisms by which you can get group and waveform differences. and certainly like Brad's real point of showing the FOOF plots, and especially the FOOF plots out to really high gamma, is that you want to take in the whole spectra, and and because he's got again, like this is a lot of ECOG data and a lot of macaque data. I'm pretty sure. Certainly ECOG, but like he's getting good high gamma values, and typically we just don't have that, or we've cut off way below that, and so yeah, I think it's definitely a paper that would be very worth the time coming back to, and so no, not so much on the timescales, but like it's I just recently became familiar with all the genomic analysis tools, and certainly Go tools for the kind of stuff that he's doing, the open data sets that he's utilizing from Allen Institute, which I think is, again, it's a really cool. He talks about how the fact that this is work that's not doable by one lab, and yeah, but.
So do you want to give this summary of it, Morgan, for people who haven't read it? I don't think.
Well,
Really gauge
I'll
that.
give a summary. I just read it. You just watched me.
Okay.
The how do I stop sharing here? It all boils down, I would say, to this idea of time scales, which seems to be like over what period the neurons correlated with itself. And they predicted that that might be different in different parts of the brain and at different times of the day or different tasks. And so they first simulated that, and they measured in the simulated data, they showed that you could measure quantitatively those changes in time scale, whether the neurons are like quickly autocorrelated or over a long scale autocorrelated. And then they used that quantitative measure on a number of data sets to investigate the rest of their paper, the localization and the cognitive relevance. And so I guess like the linchpin is this idea is obviously whether their measure actually measures what they think it measures, and also whether this autocorrelation happening at different time scales is important, I guess.
Yeah. I mean,
or is the signal, or is it just a corollary of something else? But yeah, it seems it's cool.
I mean, he did say that this was not an experiment so much as like trying to gather a number of different data sets to better understand the problem.
Yeah, cool.
And yeah. And like he said, like this was stepping out, like this was a real collaboration with a lot of different groups with a lot of different kind of skill sets. And yeah, but more food for thought. And
or the question I always ask in like people's candidacy is like, if you were designing a robot, would the robot's brain need to have different time scales in different parts of the brain? And what function would that have in the functioning of the robot? Why is that a good thing for computation?
Yeah.
And maybe I just skimmed the paper. Maybe they do get into that in the discussion.
No. I mean, it was kind of like higher order areas would need this longer time scale for better integration across other areas.
Right.
I mean, in broad strokes. Like
okay, and then the benefit will be that maybe it's a predictor of mental health, or it can be used for performance changes, or yeah, that's cool.
Well, one of the interesting parallels I found a while back was looking at the comparisons between the way the brain is structured and the way that we've come up with what we call the OSI stack. The 7 protocol layers for transmitting information. And what you'll find is, if you look at it, they kind of define 7 layers, 1 being physical, 7 being your most abstract, your application layer or whatever. And you see the same kind of thing, which is that your lower level layers, like your Ethernet layers and so on, have massive amounts of packets, but they tend to be very small, and the data in them is not very significant. So when you're dealing with low level stuff, it's very useful to have super high bandwidth small chunks that are not super relevant themselves. And as you go up the complexity stack, you end up with sort of the highest level, the application level, which is what the user interacts with. But there's all kinds of reasons that it's more advantageous that when you have simple representations to do it in a larger quantity and a lower complexity. And similarly, there's reasons that it's advantageous that as you move up complexity, you move the number of cycles down and you make them more meaningful. So, I mean, I'm sure this is stuff people know, but what I find fascinating is when you provide yourself the same challenge of how do you construct this general layer, and we come up with something that seems to make conceptual sense, I find it fascinating to go back and say, well, maybe some of these same constraints held here.
Mm-hmm.
Yeah.
That's, and I guess it makes sense that it would happen across regions and hierarchically, but it's interesting that it would happen within a region during different cognitive tasks, or like that it would be relevant for how much you're trying on a task, that it would speed up or slow down.
Yeah, I do think that stuff is really cool. But it really does come down to like a complexity and a resource constraint thing. And it's almost like there's no way around it. Anytime you're trying to, distribute multiple paths, I think you're going to end up with kind of this stacked architecture where it makes sense to have components that operate at faster scales and at slower scales. So it is really interesting, just like you were saying, to see the parallels.
Yeah, I put a link in the thing for this article that was kind of influential, I guess, a little while ago. It's called "Could a Neuroscientist Understand a Microprocessor?" And I don't think they described what you described just there, which is like timescale separation in software hardware systems. That would be like a nice addition to the stuff they're talking about there, or that general picture. They'd be like, yes, a neuroscientist could understand the microprocessor if it's got timescale separation and hierarchies.
Yeah, and that's where I found networking to be interesting, because in and of themselves, the components aren't interesting. But when you want them to communicate, you run into all kinds of limitations. How much do they communicate? In what way? What do you do? You know what I'm trying to say? So that's where the real complexity comes in. It's like, and you just run into massive power and processing limitations and all these other things. And I have to imagine that we have those same problems. Like, if something we were doing was going to be too computationally intensive, we would just start pouring sweat. Well, that doesn't happen in real life too often. So there seems to be this understanding of resources and scaling. Same kind of thing you see.
The other comparison point is deep neural networks, right, which also just naturally form, like, start tracking dependencies on slower scales the higher up you are, and the higher up, further along you are, deeper you are in the network.
Well, this paper is also by the guy who got Neuromatch going, and and we'll be running Neuromatch Academy this summer. That looks like 3 weeks of intensive computational neuroscience and machine learning. But looks like good stuff. So yeah, anybody have any last thoughts for the evening? Jason, super glad you joined us.
Yeah, thanks for inviting me.
No, definitely.
Very interesting.
Yeah. I'll follow up with you if I could on the recorder, and I'd love to see that out there.
Yeah, for sure.
Cool. So I need you to talk to my son.
Indeed.
I need you to talk to my son about Fortnite. Yeah. Yeah.
Right.
That's why we're here.
Mm-hmm. Mm-hmm. Yeah. It's excellent. So a lot of these there are several games that have come out recently that have this concept of an AI director, which is really interesting. So the idea is this is a little routine that looks at how you're doing in the game and basically dynamically adjusts it based on your performance. So the most well-known game that used this technology was from Valve a few years ago. It's called Left 4 Dead and Left 4 Dead 2. And so you basically have this AI that's looking at how you're doing. And if you're having an easy time of it, throws harder opponents at you. And if you're having a hard time of it, makes subtle changes to make the game easier. So I think that maps really well to the idea of having some input from the user in terms of how they're experiencing the game and using that kind of concept to adjust it and make it more lucrative. In terms of what these companies are trying to do influence wise, it's incredible. Activision 2 years ago filed a patent, and I just thought this was the wildest thing. So if they see you go into the store and check out an item that you're considering purchasing, let's say in Fortnite, right? They have a patent on this where what they will do is they will realize, oh, okay, this person's thinking about buying this gun or, this item in the game. So they will intentionally find a player in the matchmaking pool that is skilled with that weapon and match you up against them so that you get destroyed by it, right? And so that you feel the pain of not having that advantage. So you go, oh crap, I really need to get this thing, right? Look how good it is. And then, and this is the most amazing part, then if you buy the gun, it will find some really crappy matches where your opponents are really poor and immediately put you in those matches once you've bought the gun. And the reason is they want you to feel as if you're performing well as soon as you've bought it. So you want to talk about a level of psychological trickery. It's literally, hey, we saw you looking at this item in the store. First, someone that has this item is going to beat the hell out of you. And then if you do purchase the item, you get to go share the love with others. So it's a pretty incredible thing. Right. 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 Mm-hmm. Mm-hmm. It's a big thing. Yeah, and honestly, whether we're talking about movies or games or whatever, it's this fascinating moment in time where the companies that are selling the product to a user probably have a better understanding of what that user is experiencing than the user themselves. And I just find that bizarre. Like it's a weird thing.
Well, I want to thank everybody for joining us this evening. It's been great, and yeah, we will reconvene next week. Join us Monday for NeurotechX Paris. We'll be definitely talking with some of the Paris Machine Learning Application Group people, and just about machine learning and deep learning. By the way, there's a new version of Brain Decode, which is the Freiburg University package, or EEG project that Robin presented at BCI 101. And also the Marika Challenge. There's there was I think 16, 17 submissions, and yeah, the top prizes were claimed by Leuven and Sydney, and apparently, well, we'll hear. Hopefully, Yannick will join us in a couple of weeks. Week or two, and they'll be able to say more about what's going to come out of that in terms of. I mean, there's going to be two papers coming. I think I can say there's going to be a couple of papers coming out of this, and the main thing being that that the people backing it were super happy. The research group that made this publicly available data set we're also super happy with the winning submissions, and hopefully we will get back to processing the the larger, the larger data set, which is, 10 times the size of just the seizure stuff. And yeah, John wasn't here. John didn't join us, but we're going to definitely get some updates to that particular server. There won't be GPU updates, but Jitsy's rolled out some interesting integration features with Jupyter Lab that we're going to try and test out with just with the smaller that EEG NEARS data set. Yeah, and as I say each week, thanks to the videographers. Ryan, I'm sorry, I forgot you last week. I think I forgot to say something last week, but I don't know if you were recording today, but I know you uploaded a lot to the YouTube channel that we can check out. And yeah, thank you, Alex. And yeah, so get in touch if there's something that in particular that we can cover, or if there's changes to the form, or if there's things we could be getting done. Let me know, and we'll follow up next week. All right, take care, everyone. Good night.
See you guys.
See you guys.
Bye.